based on the friction, and the second part will be about elements of rigid body dynamics, which we will see after friction. Basically, this meaning of this friction is, in general concept, if you have two bodies which would have some kind of motion in between, then only the frictional concept will be come into existence. Because friction means generally you require two bodies which should have a contact between each body, right? Say for example, like in the previous chapter I have used the example of just rubbing two hands, which means one body is in contact with other body. That's a motion. So for this kind of motion, or when a body is in contact with other body, there will be some resistance will be developed in between these surfaces of the bodies, so that the movement of one body will be resisted by other body, which means there is some kind of friction is developed, because of which the purpose of moving one body in a direction is being resisted, which means it will not stop the movement of the body, it will resist to an extent. Say for example, I am just applying a force of 10 Newton for this hand, which I am going to rub with the other hand, left hand. So when there is a friction between two body surfaces, the speed of force of 10 Newton will be at some percentage will be disturbed, which means it may reduce to even 9.5 Newton or say 8 Newton, whatever it is. The 10 Newton force cannot be exactly applied because of the frictional resistance occurring between the two surfaces. Okay, so in that case, whatever the body we consider in general, the friction, in the sense, this can be directly taken as your tangential force. Tangential force, because normally friction will occur when two bodies in contact. Maybe it is in vertical direction or in horizontal direction, whatever it is. The bodies are in contact means the friction force will be in tangential direction only. Is it not? Because say for example, I am just keeping a block, say this is a duster, right, or a stone, whatever it is. I am just keeping in a rough surface. This surface is a rough surface, right? I just want to move this body by applying a force of say 8 Newton or 10 Newton, whatever the value it is. When I am trying to just push this body from a left hand side to the right hand side, the contact of this body, the area of surface contact within this body, say number 1, and to that surface will have some restriction due to this rough surface, and that particular friction developed, it can be directly called as friction or it can be called as frictional force. This is again your basic physics, but still technically you need two bodies to have frictional force, and one body cannot be defined for a friction because there is no purpose. When you have a sliding or moving or rolling, a kind of contact only, the friction comes into existence. Okay, so this friction can be subdivided into two, that is again your static friction and dynamic friction. Dynamic friction, this I could call this as kinetic friction, because it's just by denoting the motion. So the static friction, dynamic friction is a subdivision of this friction, and this friction is also subdivided as something called a dry friction. That means friction occurring when bodies are in dry condition, or the other name of this dry friction is called Coulomb friction, named under the scientist Coulomb. Coulomb friction, right? Or is otherwise it's called, the other subdivision is called fluid friction. That means the friction even occurs between the fluids. Suppose you have a container of oil and water in the same container. What will happen actually, due to the density of this water level and oil level, you will have some kind of zigzag motion of the particles inside. That will also develop to a friction. which needs a different amount of force. So that's also a kind of friction. But we are not studying anything about fluid friction in this unit number 5. We are just bothered about dry friction, or it is very well known as Coulomb friction. And this Coulomb friction, it is just by name of the scientist Coulomb, and this has been subdivided into again two. That is again static and dynamic. What we are interested is to study about Coulomb friction, in that static and dynamic friction. The static friction will be denoted in another symbol, and dynamic I told it's in sense of kinetic, because it's either static or dynamic. Kinetic is nothing because of kinetic energy, because when a body is in motion, it comes into picture. Even there is static friction also, because when you keep a body statically in a place for a long time also, between the surface and the body, there will be an amount of friction developed. It's called static friction. And the main parameter under friction is something called coefficient of friction. Coefficient of friction. It is the ratio between a maximum frictional force, which means I can take it as a limiting force, the maximum value of the frictional force, to that a normal reaction applied to the body. In the sense, suppose I have a body which is being placed in a surface. It is mandatory that this particular body should be supported by some means. That is the reason it is kept in equilibrium condition, is it not? This body will have, suppose say it is having a weight of say 100 Newton or whatever mass or weight it is. This body should rest in a place, which means this may be a table or a surface, whatever it is. That particular surface or that body should be supported by the surface, is it not? That means this much weight, 100 Newton. I am just standing in this floor. What is the meaning of this? This floor is supporting my weight. That is the reason I am able to stand, either straight or whatever it is. That's called the equilibrium condition of the body. So for this body to rest, I need always a normal reaction which is actually exactly perpendicular to the plane of body will be applied. Which I mean to say, this normal reaction is equal to this weight of the body. Say weight is 100 Newtons. Right? So when 100 Newton weight is been placed, or 1 Newton, 10, whatever it is, if there is a weight exists, for that a particular plane, you take x, y, z or zx or whatever the plane, perpendicular to that particular plane, you should have a normal reaction, which means that is the supporting or opposite reaction which will keep that body in stable equilibrium. Right? So this coefficient of friction, it is the ratio between a maximum frictional force. In the sense, suppose I just want to move this body, as I told you, I am just applying a force. Say I need not take any value, just take a symbol P. This force I am applying, the body is going to move. When it will move actually, there should be, I have to overcome a value of friction which is being existing in this contact surface. Which means I am trying to moving this duster, past my hand. I am just keeping it in this way. I am just applying a force. If there is no friction, it will immediately pass off. When these two bodies in contact, obviously the area of contact and the place where it is touching the hands will have some friction force. That frictional force, if I overcome only, it will pass on to the next next point. So that particular frictional force, the highest value of that force is called your limiting friction. Limiting friction. That means you have friction here. What is the maximum frictional value? It's called your limiting friction. That I can show, because normally when a body is moving towards, this is the right hand side, it is moving, I say right hand side, the friction will be always in the opposite direction, because frictional force is the force which will resist the movement of the body. So obviously I will write the frictional force, say in terms of F, the symbol is F, is my Mn frictional force is denoted by symbol F. And what is the maximum limit of that frictional force? That will limit, show by letter M. It is the maximum frictional force which is opposing the movement of this body. So this I call it as a limiting friction. Limiting friction. Right? So this coefficient of friction is a value which is the ratio of your limiting friction and the normal reaction. So I can write, this symbol is given by mu. Okay? So this mu will be your Fm, that is F suffix m. It is not F into m. Please remember, it is F suffix m. Limiting friction by N suffix R. N suffix R is your normal reaction. I could always write this N suffix R is equal to W. Please keep it in mind, because whatever the amount of the load or the weight of this particular body is there, for which the normal reaction will be resisting the body. See, my weight is suppose 80 kilos. I could be able to stand in this floor. If there is no reaction in the opposite, in this floor, I will be, digging off inside. That is the meaning. There is some support to see that my load is being withstood. Withstanding the load. That is the meaning of this normal reaction. So the coefficient of friction is a parameter which is the ratio of your limiting friction. Limiting friction means it is frictional force only, the maximum point of the frictional force. Which means if I cross, say suppose this frictional force is some 10 Newton and my applied force is 8 Newton, the body will not be in equilibrium. Because it will either come back, that is, it is reposing. It cannot go forward. Which means I should have at least a value of 10.5 Newton. It will be more than this, so that I will cross the point. Right? So limiting frictional force is a limiting value which will resist the body for the moment. So that we have to apply a little bit more force so that to cross it. So the purpose is to know what is the amount of friction developed within this surface and the body. Okay. So this is how you are just starting with friction, which is a static and dynamic. Static friction we are not much bothered, because a body is in static condition, friction will be developed naturally. When we are starting just applying a force to the body only, you go for a dynamic value, which is almost for again 10. That is again half mv square. Your mass and velocity square. Right? So in this, your coefficient of friction is a very important parameter, which is a ratio of your limiting friction and normal. Right? Okay. Then in this, as I said, the tangential force, or it can be called as frictional force, is the main idea which we have to study about, analyze about. Say suppose I will have just choose a body. This is a body which is in a horizontal plane, horizontal ground. Resting in a horizontal ground. Here I am applying a force of, say, P. Right? This body will have suppose 100 Newton value. This is one kind. So there will be a friction developed between these two surfaces, and it will have to overcome that. And this is sketch number 1. Sketch number 2, I can take the same body, okay, with this rough surface. See, this indication marking denotes that it's a rough surface, which means friction will be there only in rough surface. A smooth surface means, say for example, if I have this particular floor where I am standing or walking, if you don't have a friction in the floor, you will fall down. Is it not? A very smooth surface, using your floor, granite, whatever it is. If it is so smooth, your shoes you cannot step up in the walking area. You will slip off. That's it. It's a simple idea that the markings denotes that it's a rough surface. That is the meaning. Nothing else. You should not confuse with these markings. But you will have to indicate in every diagram that this marking shows that it's a rough surface, or you indicate with a wording, rough surface it is. Fine. So in the second sketch, I'll again introduce the same amount of force P with 100 Newton your body weight, as well as I could have a fine. Now this particular force, I'll be transferring it into this right hand side and show that the force is applied in this fashion, which means it is in an inclined fashion. Here it is an exactly horizontal force which will tend to body, move the body. So you will have a normal reaction and frictional force opposing, that is your normal process. And now this particular force, in the second sketch I have shown a force with an inclined fashion, for which this is my angle theta. Okay, and this angle theta, when a force is inclined, what is the basic idea? What we studied in chapter number 1? Any inclined force will have to be resolved into two components of one horizontal and one vertical. Is it not? Always we are bothered about an angle with the horizontal level. Suppose this is my force of inclined fashion. I should obviously draw an arrow mark indicating this pointer at a vertical line as well as an horizontal line. Just means I am converting this inclined force P into one force of horizontal, other force of vertical. Right? So what we used to write, this P is P cos theta and this is P sin theta. I have always told you, always write cos for horizontal side and sin for vertical side. Wherever may be the angle. I can write for this angle, what will be this angle now? 90 minus theta, is it not? That's it. But you should not write or change the sine or cosine in the opposite side. The horizontal side is always cos and vertical is always sine. In order to avoid confusion, which will start from unit number 1 and it goes on. I was telling in every unit that it carries good till unit number 5. And this is unit number 5 now. Right? Now, this force which is acting away from the body. So here what should I write now? I can introduce an horizontal and vertical force and change the components. Now here, this P cos theta, which is an horizontal value, which will pull the body towards right hand side. Is it okay? Which means I am bothered about the direction of motion of the body and the opposing force. Because friction means I just want a movement. When I am trying to move the body in the right hand side, friction will oppose in the opposite side, left hand side. When I am pulling, trying to move the body in the left hand side, it will be opposing to the right hand side. That is the logic. Right? Now here, P cos theta is moving towards right. Then where will be my friction force here? So normal reaction is always acting upwards and my friction force will be left hand side. F suffix M. Now, in the next sketch, okay, the sketch number 3, I will indicate the same diagram with a different fashion of the applied force, which means I will show this sketch in this slide. Now see the force. What is the fashion of this force now here? It is pointing towards this, say, body. Now here my normal reaction is as it is. Okay, weight of the body W is as it is. Here also I can write this is my weight of the body, normal reaction. Here my friction force is opposing Fm is here, or Fm or F, whatever you can write, whatever it is, limiting friction. Okay, here what to write now? Here the P cos theta, why I told P cos theta here? P cos theta is the force towards horizontal. P cos theta is the force which will pull the body towards right hand side, and sin theta will be, say, it is in the upward force. It goes along with your NR, normal reaction. And here, what should I write now? I am going to resolve the component into, resultant this value into two components. How is that? One is, this is P cos theta again, and this is P sin theta. Okay, again the angle is here theta. So the same thing, I can show like this, or show here, P cos theta comes here, and P sin theta will be opposite side. Now here, the resolved component P cos theta will try to push the body towards left hand side. And kindly remember, we are bothered about the direction of motion of the body and its opposing resisting force, that is frictional force. Now where will be my frictional force here? Fs suffix M. It will be opposite to that. When my direction of motion is in one side, opposite to that only will be my frictional force. This is my direction of motion, right? So frictional force will be opposite. Again here, what is my direction of motion here? P cos theta is this. So this is my direction of motion. Okay. So this is how you can categorize how does a frictional force acts and what is the weight or your components can be divided. The next step is any inclined force is generally a resultant value, is it not? Because an inclined force, if I write whatever inclined force we are writing, which means an inclined force will have to form a component of one vertical and horizontal. So we will have a resultant value. What I mean to say, the same body, if I take, this is my what is this, inclined value, or you can take, this is my NR. NR is normal reaction, okay, and this will be my FM. What is this? Frictional force. So I am just writing this arrow mark in the left hand side, or it can be right hand side depending on the direction of motion, and this resultant value will be like this. Is it not? And this value, I will take it as phi, and this phi is an angle, it's called angle of friction. Angle of friction. This is an angle between the resultant value and the normal reaction. It is not the angle between your frictional force, limiting friction and normal reaction. Then phi is known as the angle of friction. There is an angle between the resultant force and the normal reaction. So this could be written as what? It is the root of your Fm whole square plus Nr whole square. Is it not? Resultant is an root of this. Is it not? Now what will I write my tan phi? Tan phi is what? Opposite by adjacent side. Phi is here. What will be my opposite side? Again Fm by Nr. Again, where is this Fm by Nr? This is almost equal to again mu. Suppose, which I have erased this, mu is your coefficient of friction, Fm by Nr, which I already defined. So this is, if you compare this mu and this, what will you get finally? Mu is equal to tan phi. Clear? So the angle between, or tan of the angle between your resultant force and your normal reaction is equal to coefficient of friction. That is the meaning. It's improved. Mu is equal to tan phi. Okay, and finally remember, this phi is an angle known as angle of friction, and angle of friction is the angle between your resultant force and the normal reaction. That's it. So based on this, if you say take Coulomb friction, definition of Coulomb friction, what is dry friction, what is Coulomb friction, and static and dynamic, all these 2 marks or say 4 marks questions will come, and to prove that, to show that what is mu is equal to tan phi, that means mu is coefficient of friction is equal to tan of the angle between your normal reaction and resultant. This also you can show that. So this is how the theory goes, and if you solve one problem in this, it will be better to understand, right? Now before we move on to a problem to be solved, we'll just see what is known as impending motion. Impending motion, which means, so as I told, there is a body kept in a, say, rough surface, okay, you are just applying a force in any direction, either right or left. So as known, the weight of the body will be towards the vertical side, and you will have a normal reaction, right? The particular point when the body start moving, which means when your friction is in the opposite side, frictional force or limiting friction, whatever it is, the opposite side which is resisting the motion, the particular point of the motion when the body is just start moving, I can say just moving, just started to move or just start moving, okay, this particular point wherein it will, that means the applied friction have to be overcome. The meaning is either the applied force, say suppose your applied force is F. I did not write P or F rating. This applied force F has to be either equal to your say limiting friction, or it is to be greater than your limiting friction, or it should be less than your limiting friction. Is it not? These three conditions are always existing, because if your applied force is less than your limiting friction, it will not move, right? If your applied force is equal to limiting friction, it will be as static. It will be in the equilibrium condition. It will not either move towards right or left. But only when your applied force is more than your limiting friction, that particular starting point of that movement is called your impending motion. It impends. It starts moving. It just starts moving. So this can be shown again in your same with this is a direct horizontal force, which I previously told us, shown as a sketch, using a inclined force, again either in out of the it's like a pulling or it is pushing, whatever it is. The same sketches of the previous topic holds good. So this is called impending motion. Impending motion means, why this is required to learn is, these three kind of possibilities exist always, because either the applied force is equal to the frictional force, which is equal, will keep the body in normal equilibrium condition. If it is less than that, body cannot move. More than that only it can move, right? So with this previous topics on this, we can solve one question to see that how does your value differ. And before this, you will have one more step also. That means, say first I was talking about your body is in only in horizontal, body is kept in horizontal plane, but the force may be either horizontal or in the inclined plane. Say suppose the body itself is kept in an inclined plane, in the sense with some angle, which means there are two bodies, this is body 1, this is body 2. Okay, now I am applying force here in this fashion, and this will be in this fashion. Now what happens? What are the possible normal reactions, the self weight of the body or whatever it is? This also is one step, wherein these inclined forces, when the body is kept in inclined direction, okay, there also your impending motion comes into picture, wherein I can indicate an inclined angle with some plane with an angle theta. Here I will have a body, okay, the body weight will always act downwards, and it is obvious that normal reaction will be always perpendicular to the plane of the body, okay. Now naturally your theta or some angle, this angle is your cos value, because when you have the forces in the inclined direction or body in inclined direction, this will be your weight into sin theta, is it not? And this will be your weight into cos theta. The angle between normal reaction and this plane will be your theta, and W cos theta will be always in perpendicular to the weight of the body, and sin theta will be in the opposite direction. So this, the movement of this force either in direction of the moving, means if this is an inclined plane also, what is the meaning? Only when suppose this body is moving in this direction, this is the direction of motion, what will be your friction here? And in the same fashion it is, friction will be in the opposite direction, friction force. So if your Fm is equal to that particular value of your sin theta, what will happen? It will be in equilibrium. If it is more, sin theta should be more, so that the body starts slowly sliding down. That particular sliding point, I can say it's called impending. Impending in the sense is just start moving. That means it should overcome the resistance value. Friction resistance will be overcome, and then start just moving. It's called impending motion. Right. So with this C1, we will see one problem to be solved. Now it's a simple problem here. A body of weight 100 Newton is placed on a rough horizontal plane, okay, which is pushed by a force of 45 Newton. Right. Pushing means the applied force is a value of 45 Newton, which is given by symbol P here, okay, as shown in figure ABC. There are three figures differently given. What is the difference here in this figure? first figure, say suppose this is A, okay, just with an horizontal force directly P, applied force P with 45 Newton value, and in the figure B the applied force is an inclined force which is in this fashion, that is the point of application may be away from the point of application, the forces, and the angle is 25 degree, and the figure C again this value is 45, P is 45, here the point of application is towards the body, that's it. Now okay, that's it. ABC 2, just cause sliding over the horizontal plane. What do you mean is just causing? I explained what is an impending motion before this topic. Just causing moving means it is just start moving. We are applying a force, a resistance is there, friction resistance is there. We have to overcome that particular resistance and the body starts just moving. Is it not? So just cause sliding over the horizontal plane. Right? Now determine the coefficient of, so when it say it is read that just cause sliding only, the application of your equations of equilibrium is possible. Sigma H sigma V is possible only for this condition. Just start moving. Which means I have already told shown that what is impending motion is. Your FM, applied force is F. It should be equal to either the friction force to be kept the body in equilibrium condition, or it should be less than that. If it is less than that, body will not move. If the force is more than Fm only, it will move, right? So determine the coefficient of friction in all the three cases. Now before going to the answer, first we will write the free body diagram, or what are all the possible forces here. So this is by normal reaction. You are applied load 100 Newton W, okay. Then what else is there? Again for here, again normal reaction, okay, and load applied is 100 Newton. What about this one? Your inclined force. Instead of writing P, I will write what is the value given? 45 Newton here. So I will write 45 Newton. Then kindly remember, this is an inclined force. We have to convert it into two components, horizontal and vertical. I will write 45. It is cos 25 degree. This angle. Again 45 sin 25 degree. Is that okay? Then this sketch will have normal reaction as it is, opposite to the weight of the body or load of the body, and here the inclined force is like this. So this will be your P is again 45 here, so it's 45 cos 25 degree towards left hand side, and vertical direction down you will have, let me write the weight here. Here we have 45 sin 25. That's it. And what is to be left here? What is left without writing? When body is trying to, okay, I will first tell the direction of motion, then we will write the frictional force which is opposing. So where is the direction of motion here? First sketch is this. I write dm, direction of motion. So obviously friction will be in the opposite side, Fr. So you will let F, okay. Should I change it? No, F I can write. This is 45 Newton. Here, where is the direction of motion here? This 45 cos 25 is the horizontal force which will pull the body towards right hand side. So here, when its direction of motion is here, dm, your frictional force will be, F will be in the opposite side. Okay? Whatever it is. Frictional resistance I can write Fm or F, can show. And here, what is this again? 45 cos 25 is acting toward left hand side, which will pull the body towards left hand side. So my friction resistance will be towards right hand side. That's it. Now we should go for sigma H and sigma V values and find out the, what is the record here? Determine the coefficient of friction, mu value. See here, for the first sketch, I will go for applying sigma H is equal to 0. Horizontal force. What is horizontal force here? Just 45 is acting towards right hand side. Your F suffix m frictional is acting towards left hand side. Minus Fm is equal to 0. What is the meaning? 45 Fm is equal to 45. Frictional force is 45. Okay. Then apply sigma V is equal to 0, vertical force is equal to 0. Count all vertical forces. What is here? First is NR acting up, 100 Newton acting down. Anything else is there? No. Is equal to 0. So it leads NR is equal to 100. Now what to do? You need to find mu. What is mu? Fm by NR, N suffix R. What is Fm value? 45. NR is 100. Say you will get some, I think 0.45 you will get, is it not? So your mu value is, friction, coefficient of friction is 0.45. This is the value. So like this, you apply sigma V, sigma H for all this, you write down, you can get the value of mu. Okay, the values are maybe, only thing is the concept you have to understand. But now what you are doing here, sigma V, say for example here sigma H is what? Horizontal forces. One force is acting towards right hand side is what? 45 cos 25 is the force acting towards right hand side. Positive. Fm acting left hand side negative. Then what else horizontal here? Nothing. So you just can write directly. Fm is equal to 45 cos 25. Cos 25 you use your calculator and multiply to 45, that is the value. Some value you will get. Like that you go for, this is for sigma H. Then sigma V, then find the answer. So all this you have to find the mu value. Remember I am not writing the answer here. You will have to rest, practice and write. One or two problems you solve with this, you will understand. But you should understand how we are changing the inclined force into required components and find out the mu value. That will be easier way of understanding.